to talk about oxidation and reduction, how to determine oxidation states, and we're going to examine oxidation and reduction reactions. Oxidation is the loss of electrons from an atom. So during the oxidation process, there's an increase in oxidation state. Reduction is the gain of electrons from an atom. In the reduction process, there's a decrease in oxidation state. A redox reaction involves the transfer of electrons from one element to another. For us to examine an oxidation-reduction reaction, we must determine the oxidation states of all the atoms in that reaction. So standard state uncombined elements have an oxidation state of 0. Elements that are freestanding, that are not bound to any other element, like Xe, He, aluminum solid, even diatomic molecules like Cl2, O2, F2, S8, which is made up of one element. These all have oxidation states of 0. Monatomic ions have the oxidation state that's equal to their charge. So sodium plus will have an oxidation state of +1. Calcium 2 plus will have an oxidation state of +2. The oxidation state for oxygen is usually -2. However, in peroxides, oxygen will have an oxidation state of -1. When oxygen is bound to fluorine, like OF2, oxygen will have an oxidation state of +2. The sum of the oxidation states in neutral compounds is 0, and the sum of oxidation states in ions is going to equal to the charge of the ion. Let's take a look at an example. Let's determine the oxidation state of all of the atoms in MgCl2. Now, Mg is bound to another atom here, so it is behaving as a cation from group 2. So the oxidation state for Mg is +2. Chlorine is in group 7 and has an oxidation state of -1. Rule 4 says that the sum of the oxidation states in neutral compounds is 0. So let's double check that. There's only one atom of magnesium, so +2. There are 2 atoms of chlorine, so 2 times -1. And this entire compound is neutral, so this all has to equal to 0. +2 plus a -2 equals 0. So we did that right. Let's take a look at copper 2 sulfate. We want to assign oxidation states to every single atom in this molecule. Oxygen will have an oxidation state of -2. Now sulfur can have multiple oxidation states, but in this molecule it is a +6 because sulfate, SO4, has a charge of 2-. So when I add up these oxidation states, they should equal out to -2. Copper is a transition metal, and it can have different oxidation states. So let's solve for copper. We're going to add up the oxidation states. There's only one atom of copper, so X, plus there's only one sulfur. There's 4 atoms of oxygen with an oxidation state of -2, and this should all equal to 0. So X plus 6 plus a -8 equals 0. So X should equal to +2. So the oxidation state for copper is +2. Let's take a look at another example. H3O plus. Now, oxygen is our exception. It has different rules. But we know that hydrogen is in group 1 and it will always be +1. Oxygen is my X. I don't know what oxygen is. There are 3 atoms of hydrogen. There's 1 atom of oxygen, and I don't know the oxidation state. And this entire compound has a charge of +1. So this all has to equal to +1. When I solve for X, I get -2. So the oxidation state for oxygen is -2. Let's do a more difficult one here. CrH2O6 3+. Now, oxygen is going to be a -2. Hydrogen is going to be a +1. Chromium is in my transition block, so this one has varying oxidation states. So let's go ahead and solve for X. There's one atom of chromium. There are 12 hydrogens. And there are 6 oxygens. And this entire compound has a charge of 3+, so oxidation state of +3. X plus 12 plus -12 equals +3. So X has an oxidation state of +3. So chromium has an oxidation state of +3. Let's go ahead and examine the reactions now. Once we figured out how to determine oxidation states, we can go ahead and examine redox reactions. Before we do anything, we have to assign oxidation states. So let's go ahead and do that. Zinc is an uncombined element, so it has an oxidation state of 0. Copper ion is going to have the oxidation state of its charge. Zinc is going to have the oxidation of its charge, and copper is freestanding, so it has an oxidation state of 0. Now I want to examine if the atom loses or gains electrons. So I'm going to take a look at zinc, and I'm going to compare that to zinc 2+. It goes from 0 to +2. This loses electrons, and this is called oxidation. Zinc is going through the process of oxidation, so this is called oxidized. And the ending is very important. That ED ending is important. Because zinc is oxidized, it is allowing copper 2+ to be reduced. So this is called a reducing agent also. And you can see this on a test in a multiple choice question set. So zinc is oxidized, which means it is the reducing agent, and that ending is very important. Let's take a look at copper 2+. Copper goes from 2+ to 0. That means it gains electrons, and this is called reduction. So copper 2+ is being reduced with an ED, and this is allowing zinc to be oxidized. So it is also called the oxidizing agent. Now we've examined our redox reaction. We figured out which atoms are being oxidized and which atoms are being reduced. We also have to come up with half reactions. So the oxidation half reaction. So we see that zinc is being oxidized. So zinc, something happens to its electrons where it starts off with an oxidation state of 0 and goes to zinc 2+. The atoms have to be balanced out, and the charges have to be balanced out. So we have one zinc on the left, one zinc on the right. That's good. On the left side of the reaction, we have a total charge of 0. There aren't any charges. And on the right side, we have a total charge of 2+. We need to balance the charges out with electrons. I need the 2+ to somehow equal to 0. So all I have to do is add 2 electrons, because remember, electrons are negative. So 2+ plus a -2 is 0. And that does follow the directions of my oxidation. Oxidation is the loss of electrons, and I am showing a loss of electrons because it's on the right side of the reaction. Let's talk about the reduction half reaction. Copper 2 plus, something happens to its electrons. It starts off as 2 plus and ends up as Cu with the oxidation state of 0. 1 copper on each side, so that's balanced. There is a total charge of plus 2 on the left side, and there's a total charge of 0 on the right side. So I have to add 2 electrons to the left side. Now I have a total charge of 0 on the left and a total charge of 0 on the right. And that is the definition of reduction. Reduction is a gain of electrons. Let's take a look at another example. I have 2 silver bromide yielding 2 silvers and bromine gas. Let's go ahead and assign the oxidation states. Silver is behaving as a cation, so it has a +1. Bromine has a -1. This silver is freestanding, so it has 0. And Br2 is diatomic, it has 0. So now I want to examine the oxidation reduction process. Silver, Ag plus, goes to silver 0, and this is called a reduction. And that means that the silver plus is being reduced. So not the entire molecule, just the silver plus. And this is also called oxidizing agent. Then I see that Br starts off as Br minus and ends up as Br2. This is called oxidation. So the Br minus is being oxidized, and this is also called the reducing agent. So now I have to come up with the half reactions. I like to start off with the oxidation always, so oxidation, half reaction. I see that the Br is what's going through the oxidation process, but I have to be careful. It is the Br minus that's doing the oxidation, not the entire molecule. And there are 2 units of that atom. So I have to take that into consideration. So 2 Br minus, and I have to show the charge, electrons get transferred, and it becomes Br2. I have 2 bromines on each side. I have a total charge of a -2 on the left and no charge on the right. So I'm going to have to add 2 electrons because electrons are minus, and now my charges equal out. And the definition of oxidation is the loss of electrons, and I see that when it's on the product side. Let's talk about the reduction half reaction. Again, not the entire molecule is being reduced. Only the silver is being reduced. So it's 2 Ag plus, and it yields 2 Ag. There's a total charge of a +2 because this 2 times this +1 is +2, and there's a total charge of 0 on the product side. So I have to add 2 electrons on the left side. Let's take a look at another example. I have this reaction, and I want to try to understand the oxidation and the reduction. So let's go ahead and assign oxidation states. Iron is going to be +3 and oxygen -2. Aluminum is 0. Aluminum here is +3, oxygen -2, and iron is 0. Now I want to examine which elements are going to transfer electrons. So if I take a look at iron, iron goes from a +3 oxidation state to a 0, so that becomes reduction. And if it's going through the reduction process, then this is called reduced or oxidizing agent. Oxygen, nothing changes in oxygen, so I can skip oxygen. However, aluminum goes from 0 to +3. This is called oxidation. So aluminum is oxidized, and it is the reducing agent. So now I want to do the half reactions. Oxidation, half reaction. Aluminum is the one that's going through the reduction. So I want to still keep my charge in my balance. So 2 aluminum yields, I can't write this entire molecule because not this entire molecule is being oxidized, only part of it. And the part that's being oxidized is the aluminum cation. So this goes to, there are 2 units of the aluminum cation. So I have 2 aluminums on both sides. My charge on the left side is 0. My charge on the right side is 2 times 3 plus, which is +6. So that means I have to add 6 electrons. And that is the definition of oxidation, the loss of electrons. Let's talk about the reduction half reaction. Only iron is going through the reduction process, not the entire molecule. And there are 2 units of iron. So I'm going to say 2Fe3+, and it yields 2 iron. I have 2 irons on both sides. I have a +6 on the left and a 0 on the right. So I'm going to add 6 electrons. So in order to determine oxidation reduction, you do have to assign oxidation states and then break them down and figure out the half reactions. Good luck and keep practicing.